I'm Anil Kumar sharing with you solution of a question which is for John. John, thanks a lot for sharing this excellent question. Let us see how to solve such questions. Consider the function f where f and f dash are both differentiable. F dash x is greater than 0. That means first derivative is greater than 0 for all x. Second derivative is less than 0 for x less than 0, and second derivative is greater than 0 for x greater than 0. If g of x is f of x squared, for what values of x does g have a critical number? That's part 1. Discuss the concavity of g. That's the question, right? So let's try to understand the conditions given to us. Okay, so we are given two things. One, we are given about the derivative of the function, which is f dash x. So it says f dash x is greater than 0 for all values of x. So it is always positive. It is always positive. F dash x is just positive, right? So we could treat this as a positive constant, right? To be very simple. So let's take a positive value, something k, right? Second derivative is less than 0 for x less than 0. So if we consider something here, then the second derivative is less than 0, is negative when x is less than 0 and positive when x is greater than 0. It means that the concavity of the function is kind of like this, right? So here it is concave down, and then we have a point of inflection, and then it's concave up. So this information is given to us. When we say that the first derivative is this, it means always increasing. So this I am writing about f of x, right? This I am writing about the function. Function is always increasing. Do you understand? So that's what it is. Now, we are given a new function here. So the new function here is g of x. So we are saying g of x is f of x squared. Now let's find the derivative of this function. Derivative of this function will be what? Derivative of this function will be derivative of the function times derivative of inside function, which is 2x. Do you see that? So that becomes the derivative of the function, 2x. Now as soon as you get x in the terms, g of x is no more always increasing. This is important to understand because when x is negative, this function will be negative. Is it okay? Now, the first part here, derivative, is positive. So this part is always positive. Is it okay? Not about this. How about this? Now this part will be kind of like this. Let me sketch this part. Will be negative when x is kind of this line, 2x. Is that okay? So this part will be negative to the left of 0, but positive to the right of 0, 2x term. So g dash x will be, I should write, so what we get here is g dash x will be less than 0 for x less than 0, and g dash x will be greater than 0 for x greater than 0, and x equals to 0 is a critical number, and g dash x equal to 0 is critical number. Correct, because it will be 0 here. Perfect. So part A is for what values of x does g have a critical number? So we have at x equals to 0, right? So the answer is at x equals to 0, it has a critical number. Do you understand? At x equals to 0, it will become 0. Perfect. So that is your critical number. So we have answered part A. Now let's look into part B. Discuss the concavity of g of x. So let's find the second derivative, right? So we already have the first derivative here. Let's say equation 1. And now we'll do second derivative of this function. So we can apply the product rule. So if this is the first function, then we have derivative of this as second derivative of x squared times inside function derivative, which is 2x, times what we have here, which is 2x, plus the first function f dash x squared times 2. So we could write this as, now what we can see here is the first term is 4x squared. Let me rewrite this. We have second derivative of x squared times 4x squared plus twice derivative of x squared, correct? If you see, for any value of x, this term is positive, always positive. Is it okay? Here also, we know that the derivative of x squared is positive, so twice that is also positive. So what we observe here is that the second derivative is always greater than 0. That means it is concave up. So we can say, discuss concavity of g of x. So the answer is function g of x is concave up. Correct? So that is how you could conclude. I hope that helps. Feel free to post your suggestions and comments. Share my videos, and if you like, that'd be great. Thank you and all the best.